This video focuses on large sample hypothesis testing for population proportions, better known as P. The fundamental idea behind hypothesis testing is that we're doing the following. We reject the null hypothesis if the observed sample is very unlikely to occur if the null hypothesis is true. So recall the following two things. First, the sampling distribution for P hat, okay? So the sampling distribution for P hat talks about the likelihood that you get a sample that exists if a population parameter P is true, okay? So we need to figure out the probability in which that occurs. To figure out the probability, we need to find the z-score. So we compare the sample proportion to this population proportion that we know or assume in this case, and then we divide it by the standard deviation. Furthermore, let's think about a confidence interval. So a confidence interval for population proportion estimates the population proportion given some sort of sample statistic that we know. So we use a z-critical value, which is derived from our confidence level, and then we multiply that by the standard deviation. Notice how the two standard deviations are different. We assume some sort of population proportion, so we use P when we're looking for Z. Whereas in a confidence interval, we know nothing about P, so we use P hat. Okay? So we're going to use these same two things in order to understand exactly how to perform a hypothesis test. We will use probability in the properties of sampling distributions of P to determine whether or not we have evidence to support some sort of claim. Okay? Remember, the idea behind statistics is that we cannot prove anything, we just provide evidence for or against a certain claim. So with hypothesis testing, there are three important features of hypothesis testing that we need to know. The first is the null hypothesis. The null hypothesis is assumed to be true. Okay? So we assume a true null hypothesis. The idea is that we are going to compare our sample data to the null hypothesis. Okay? One of two things has to occur. Either the sample could exist in the world in which the null hypothesis is true, or the sample does not exist in the world in which the null hypothesis is true. The second thing is what we're going to call a p-value. Okay? I will talk more about what a p-value is in class, but the p-value is the probability that the sample exists when the null hypothesis is true. So this p-value actually comes from a test statistic, better known as z-score. The third thing is understanding how to conclude a hypothesis test, and that starts with evidence. So, as I stated, we cannot prove anything. We are either going to say we have evidence to support a claim, or we do not have evidence. For that claim. So those are three fundamental things about hypothesis testing that we need to understand. And we're going to look more into that as class goes along. So let's go through the following example in order to figure this out. In June 2006, an Associated Press survey was conducted to investigate how people use nutritional information provided on food packages. Interviews were conducted with 1,003 randomly selected adult Americans. Each participant was asked a series of questions, including the following two. So I give you just one of the questions here. When purchasing packaged food, how often do you check the nutritional labeling on the package? It is reported that 582 responded frequently. So, based on these data, in particular these sample data, is it reasonable to conclude that a majority of adult Americans frequently check nutritional labels when purchasing food packages? So, To complete a hypothesis test, we must do what is called docs. It is the documentation of a hypothesis test. So there are 4 layers of docs that we must do: describe, outline, calculate, and then state the solution. I'm going to go through this very quickly, but you need to understand what are the features of docs so that when you come into class, we're able to just work on docs continuously. So back to our question. So the first part of docs is describe. So first, we wanted to describe the population of interest. So the population variable can be one of 2 things, either population proportion or population mean. In this case, it's population proportion. So the population of interest is the proportion of adult Americans who responded frequently to reading nutritional labels. Okay? So that's the first part of describing the hypothesis test we're doing, the test procedure. The second is labeling what the null hypothesis is and the alternative. So the null hypothesis is that it would equal a majority of Americans. Oh, excuse me, it would equal 50%. Whereas our alternative is that it is greater than 50%. Because if we look back on the question that we're trying to answer, is asking, do a majority of adult Americans. 50% is half of Americans, less than 50% is less than, so greater than 50% is a majority. Okay. The second part here is to outline the test that we want to do. So to test a hypothesis, we need a significance level, meaning we need to know a probability in which we would make a type 1 error, because we're assuming that the null hypothesis is true. In this case, I'm going to use 5%. So that means for every 100 different samples I use for this method, 5 of them will inaccurately reject the null hypothesis. Then we need the conditions of the parameter, meaning we need the sampling distribution conditions in order to see if this is true. Luckily, these are the same as confidence intervals. So the first is that we have to make sure that the sample data comes from a random sample. Secondly, we have to see if the population distribution is normal or if it's not normal, or we don't know, or we have a large enough sample. And then third, we have to make sure that our sample size is less than 10% of the population. So, looking back on our question, let's just see whether or not all 3 of these things are true. Is the sample random? Yes, randomly selected sample. Is the sample large enough? 582 is n times p. Excuse me, we have to do n times p, not n times p hat. So n times p, 1003 times 0.5 is equal to 501.5. So yes, the sample size is large because n times p is greater than 10, as it equals 501.5. And then n times 1 minus p is also equal to 501.5. So all 3 sample properties do match. So what comes after that is to calculate. So we have to calculate by finding the test statistic. The test statistic that we're looking for is Z. The formula that we seek is the statistic minus the parameter over the standard deviation. Okay? We use the test statistic to find the p-value, the probability in which our sample exists given that the null hypothesis is true. So, in this case, we have 582 divided by 1003, which is 58%. We want to subtract that from 0.5 and then divide that by the standard deviation. So 5 times 0.5 divided by 1003. Don't forget the square root as I just did. There we go. So our test statistic Z is equal to 5.08. So you have to write down the formula as well, write down what Z would equal, which is 5.08. So then we go to our Z tables. And this one's actually really simple, but we go to our Z tables and see what that would equal. So our Z tables don't exceed 3.5. So since it doesn't exceed 3.5, we can see that the probability would equal 100%. The p-value equals 1 minus 100%. The reason why is because this is a majority problem. It's a greater than problem that we're dealing with. So our p-value is 0. So what does this 0 mean? What this is suggesting is that one of two things occurs. Either our sample could not exist if HO is true, or HO is not true. Okay? Since we are working with sample data more so than an assumed hypothesis, we are always going to choose the latter in this scenario if our p-value is extraordinarily low. So the final step here, state the solution. So first and foremost, the solution is to write what the p-value is, which is 0. And then with that decision, you do one of two things. You either reject the null or fail to reject. So in this case, we are going to reject HO. The reason why is because our p-value is less than our significance level of 0.05%. Our p-value is less than the probability that we make a type 1 error. It's significantly less as well. It's well below 5%. Since we reject HO, what does that suggest? Well, we have evidence to support the claim that a majority of adult Americans frequently read the food packaging nutritional label. So the important thing here is that we use docs in order to conduct a full hypothesis test.